Hey everyone, welcome back on my channel Mathematician. Today in this video we will talk about these two questions. We will talk about what is mathematics and what's its nature. We will also deal with another important thing here, that is mathematics as the language of the universe, mathematics as the language of the cosmos. So let's get started. Let's go. First thing is first. Let me first of all tell you what is the origin of the word mathematics itself. So what is the origin of the word mathematics? Actually, the word mathematics, this word mathematics actually comes from a Greek word which is mu alpha theta eta mu alpha. Mu alpha theta eta mu alpha, and this is pronounced as mathema. What? Mathema. So this word mathematics actually comes from a Greek word which is mathema, and we write it down as mu alpha theta eta mu alpha. What are these symbols? These symbols are actually the letters of the Greek language, just like the ABCD of English language or English alphabet. So we read it as mu alpha theta eta mu alpha, whose pronunciation is mathema. So this word mathematics comes from this Greek word mathema, and its meaning is knowledge. What? Some say it means to know. What? So this was something about the origin of the word mathematics itself. The word mathematics actually comes from this Greek word which is mu alpha theta eta mu alpha, and we pronounce it as mathema, and whose meaning is knowledge or to know. Okay, if you want further details about the origin or about the history of mathematics, we are of course living in the age of internet, so you should have, we are living in the age of internet, you can surf internet and get the extra details about the origin and the history of the mathematics. So let me rub the board and let's talk further. Whatever I said up to now was about the origin of the word mathematics. This description does not define mathematics itself. Okay, so I have not given you yet the definition of mathematics, or I have not told you yet what is mathematics. So it was actually about the origin of the word mathematics. So what is mathematics? How do we define mathematics? Apparently this question seems very easy, but believe me, this is a question of debate for philosophers. There is no full-fledged or satisfactory definition of what is mathematics. So I will give some perspectives about the nature of mathematics, about the question what is mathematics. But believe me that this question itself is a question of debate. There is no satisfactory or final version of the definition. So what are those perspectives? Let me start from the very standard definition of mathematics that we usually find in the standard books, or you can go through Wikipedia. You will find there a lot of information what mathematics is, but I will try to simplify those descriptions. Okay, so let's go with the standard description of what the hell actually mathematics is. Here we go. So we know we learn mathematics right from our kindergarten, and there we usually encounter natural numbers. 1, 2, 3, 4. We start our mathematics journey when we are in the pre-primary or primary school, we start mathematics from these dummy, you can say, symbols, and we call them natural numbers: 1, 2, 3, 4, 5, 6. So I can say that mathematics perhaps is the study of natural numbers. Okay, so far so good. Is mathematics only the study of numbers? Study of numbers. Okay, like 1, 2, 3, 4, dot, dot, dot. If I ask this question to someone who is in the primary school, who is a student of primary school, he would simply answer, if at all, what is mathematics? If I ask him, or if I ask her, he or she would simply answer, sir, mathematics is actually what? It's the study of natural numbers. It's the study of 1, 2, 3, 4, 5. Okay. Is this definition complete? No. This definition, the definition of mathematics says the subject that deals with 1, 2, 3, 4, 5. This is correct definition, or you can say this is the correct description, but this description is not complete in itself. Because mathematics is not the thing that only deals with 1, 2, 3, 4, 5. Because there is this evidence that in mathematics we also learn about what? Figures like triangle, like square, like rectangle, like square, like pentagon. We also study about up to 10th grade. We also study coordinate geometry. So saying that mathematics is the study of 1, 2, 3, 4, 5 is not a complete definition, or is not complete description. So I can add on more things. I can write it down as mathematics is the study of what? Is the study of numbers like 1, 2, 3, 4, 5, is the study of figures like triangles, squares, rectangles, pentagons, hexagons, heptagons. Okay. It is also the study of the solid figures, the solid shapes like cubes. Okay. Like spheres, like cylinder, like cone. So mathematics is not just numbers. It's more than that. So what could be a possible definition of mathematics? So according to the stuff that we have learned up to 10th standard, in mathematics we can frame the definition of mathematics as mathematics, I will use the shorthand method. Okay, math, we can also write in place of mathematics, math or maths. Okay, mathematics is a branch of knowledge, of course. Branch of knowledge that studies what? Numbers. And in numbers we have like 1, 2, 3, dot, dot, dot. Okay. In mathematics we study numbers. We also study what? We also study plane figures like triangles, like rectangles, dot, dot, dot. And by this dot, 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 I simply mean extra. Okay. So now our definition is mathematics is the study of numbers. Okay. It is also the study of plane figures like these. Is mathematics only the study of numbers and plane figures? No. We also study in mathematics 3D figures or 3-dimensional objects. 3D figures or 3D objects like cubes. Okay. Like cubes, dot, dot, dot. I can add on more things. What else do we study in mathematics? We also study there these things, equations. Okay, equations like ax plus b is equal to 0, or ax square plus bx plus c is equal to 0. and there are various generalizations of these equations. Okay, this is just an example. Okay, we also study about equations there, and we also study about lots and lots of things. So I will put it as dot dot dot. By dot dot dot, I simply mean extra. Now, each study of each individual topic gives rise to a branch of mathematics. If we go through the standard books of mathematics at the higher level, in higher standard mathematics, when we study alone numbers, these positive integers, we dedicate a complete branch of maths for these objects. We call that arithmetic. Yeah, what? Arithmetic. Similarly, when we study these plane figures, there is a branch and we call that plane geometry. Plane geometry. Similarly, we have for this thing 3D geometry or solid geometry. Similarly, when we study equations, we study usually equations in a branch of maths, we call that algebra. So actually, mathematics is not just numbers, it's a combination of many things. In itself, it includes several other sub-branches like geometry. Geometry itself can be divided into many branches like 2D geometry, 3D geometry, and dimensional geometry. We also study about algebra in mathematics. We also study about what? One is arithmetic, second is algebra, third one is geometry, and there are many other branches like topology. Okay, like statistics. Okay, like mathematical statistics. Okay, and many more things. Okay, so what are the other possible answers to the question, what is mathematics and what is its nature? Believe me that this definition in itself is also not complete. We can add on more things to this. So let me rub the board and let's talk further. Let me add on something more to the definition. Okay, all of us know that until the advent of calculus, this mathematics was a kind of a game which was kind of static. By this I simply mean the mathematics that was established before Sir Isaac Newton was only dealing with finite things or finite processes. By the advent of calculus, we were able to analyze the situations where things were varying from time to time, or we were dealing in calculus with the situations where the given quantity or the given thing was varying with time. So Sir Isaac Newton was actually the co-founder of calculus besides Leibniz. Okay, calculus is actually a very important branch of mathematics. We call it calculus. What? Calculus. Calculus is a sub-branch of maths and it simply deals with change. What? It deals with change. What? So I can say that mathematics is also the study of change. And when we go into the roots of calculus, there comes a branch, we call that analysis. What? This is also a, you can say, pure branch of maths. Okay, and there are, believe me, many more branches. Okay, so I can say that mathematics is the study of numbers, is the study of figures, and in figures we have plane figures, we have solid objects, 3D figures, and believe me that we don't have in mathematics just three-dimensional geometry. We can talk of any dimensional geometry. Okay, so we can also say that mathematics, besides dealing with numbers, besides dealing with figures, besides dealing with equations, it also deals with the concept of change. And believe me that once the concept of calculus was introduced in mathematics, the sciences, and in particular the physical sciences, had a great leap. Okay, is mathematics only this thing that I told you? No. Mathematics is a very huge, vast subject. Okay, so it was something about it. let me tell you something more about what is mathematics. Okay, I'll be giving you several perspectives. I'll be describing it in many ways. So let's get started. Okay. Mathematics is the subject of patterns. क्या? Is the subject of patterns. Dot dot dot. Okay, let me write down a simple example. I am giving you this example to understand this statement that mathematics is the subject of patterns. I will ask you simply, I have a list of numbers over here. I am writing 2. I have a list of numbers and the first member of that list is 2. The second member is 4. The third member is 6. Now I put these 3 dots and it is a kind of question mark for you. And I am now asking you, can you tell me what would be the 4th term in this list? Obviously, it seems as a kind of mystery for us in the first sight. और बेशक ये लगता है मैं कि एक तरह का how come should I be able to tell the 4th term? It's not written there. But believe me that if you deeply look into the list, you'll be able to get the 4th term. And obviously the answer to this 4th term would be, the answer is, in place of question mark, I can replace this question mark by 8. Now the question is, हमने 4th term कैसे हासिल की? ये मैं ऐसा एक लीक थी, मैं किस पढ़े हेक्के करित? Actually, ऐस किस पढ़े हेक्के हासिल करित? ऐस रो इवन पइतमेन 3 termन, पइतमेन 3 नंबरन त्रोइस नजर, ऐत वुशस केताइमत पानु इवन लिंक इवन नंबरन, केताइमत कनेक्शन वुशस इवन नंबरन, कुस्ताइमत चीज वुशस, कुस्ताइमत रूल वुशस, कुस्ताइमत कानून वुशस, यम कानून हिसाब यम नंबर छ ब्रोंट कुन पकान. क्या छ पकान? सोई कानून यदि यथ लिस्टस छ त्रावन गौर फिक्र सान नजर, सु कानून छ मेंटली ऑब्वियस गसान. और इथु सु ऑब्वियस छ गसान, अच्छ लगन पाई ये लिस्ट कुछ पैटर्न या वो कुछ रूल फॉलो करन क्या. और इथु ऐसे हमें पैटर्न फिक्र तरन, तमी पैटर्न से छ सकन वनित क्या ये थस कोसी चोरम टर्म. गो मैथ्स में ये चीज त पढ़न टू सीक आउट द पैटर्न्स ऑफ द mental universe or mental cosmos or mental arena and to express them in the most possible compact form. By this I simply mean, when I say mathematics is the subject of patterns, by that I simply mean in mathematics we try to find out the rules according to which a given set of mathematical objects behave. And once we find that pattern, once we find that rule according to which that group or that set or that collection of mathematical objects proceed or are formed, we call that rule as simply a kind of pattern. So besides dealing with numbers, figures, besides dealing with equations, mathematicians in general, this is the general possible one of the answers to the question. So in general, I can say that the job of a mathematician is to seek out the patterns in nature. By here by nature I don't mean the physical nature, I simply mean the mathematical nature, the world of mathematics. Okay, so I hope you understand what do I mean by this statement that mathematics is the subject of patterns. By this I simply mean, by pattern I simply mean it's a kind of rule according to which a given collection of objects behaves or proceeds. Okay, is this the only answer? Are there some more answers to the question? Yes, there are, of course. So let me give them one by one. For that, let me first rub the board. Let me give you another description of the world of mathematics. Okay. Maths or mathematics or simply math is a game. What? Is a game, but mental game. What? Is a mental game. Dot dot dot. Okay. I wrote mathematics is a mental game. Okay, sir, can you please elaborate this statement? Well, I will definitely elaborate this statement for you. So, here we go. Let us suppose that mathematics is a game, and we know a game is played according to some rules, according to some laws. And similarly, the game of mathematics has its own set of rules, according to which we play this game, the mental game of mathematics. Okay. If you want to understand any game, like a ball game, for example, football, and if you really want to appreciate this game, you must first learn its rules. Only then you will be able to understand and to play the game well. Similarly, if we really want to understand, if we really want to enjoy while doing mathematics, we have to know, not just know, we have to also understand its rules. And of course, the game of mathematics has its own rules, according to which we play this game of mathematics. Okay, but remember that these rules are created by human beings. What? Are created by human mind or human mind or human beings. By this I simply mean, if mathematics is a game, it implies that it has some rules, but remember that these rules are not made by God or by some supreme being, but these rules are designed by human beings themselves. That is the difference, main difference between sciences, in particular physical sciences, and in particular physics and mathematics. In physics, the rules are created or made by God, and on the other hand, the rules in the field of mathematics are designed by human beings themselves. Okay, now every game also has arena, a field where we play that game. What is the arena of this game of mathematics? Okay, the arena, the field of the game of mathematics is our mind, is our brain. So the playground of the game of mathematics is our brain, is our mind. And the rules according to which this game of mathematics is played are also designed by this human mind, by human brain. Okay, let me give you a simple example that will elaborate this fact that mathematics is a kind of mental game. Okay, we all of us know that this subject of arithmetic, we also call it in higher mathematics what? Number theory. In arithmetic, when we learn higher mathematics, we are given some obvious truths, and we cannot question those truths. Those are actually unproved things, unproved statements, and we call them axioms. Similarly, this game of this actually arithmetic is a sub branch of mathematics, and of course it has its subset of rules. And the rules of arithmetic, according to which all the main terms of arithmetic are derived, are like these. These laws are actually the fundamental laws of arithmetic. Using these laws, we can derive all the rest of the laws of arithmetic. Okay, so like one of the laws goes like this: 1 belongs to n, where n is the set of natural numbers. Sir, can I prove this statement? No, you cannot prove this statement because this is a kind of axiom. What? It is an axiom. It is a self-evident truth. We take it for granted. We take its truth as absolute. We don't question whether this statement is true or false, because this is our starting point. Every theory, in fact, starts from some unproven facts or some unproven statements, and we call them axioms. Similarly, this is a kind of statement that we cannot prove but is given as self-evident truth, and the statement is 1 belongs to n. Okay. Besides this axiom, there are some more axioms that I will not write down here because this is not my main topic, that is how to derive the theorems of arithmetic from some given postulates, from some given axioms. This is one of them. Okay, using those postulates, I can derive all the rest of the theorems of arithmetic. So actually these axioms, these postulates are what? The rules of the game of arithmetic. And if we drop any of the statement, if we don't agree with at least one axiom of arithmetic, we'll be dealing with a completely different realm or different domain, and different domain where we will get a different result. By this I simply mean, in any axiomatic system, if we change axioms, you are allowed to change the axioms, but there is no guarantee whether it would be useful there somewhere or not. You are allowed to change your axioms at your own will, and you can do it, but there is no guarantee whether the given set of results would be of any use or not. So in axiomatic systems, you are allowed to choose any axiom, but as long as the result is derived from those axioms would be fruitful, would be of any use. So in this game of arithmetic, we choose some obvious premises or self-evident truths and play this game of arithmetic according to those rules. And what do we mean by playing this game? It simply means we use our inbuilt logic that is with us right from the birth. Okay, so this was one example of the game of mathematics where we are given some rules and we play that game accordingly. Similarly, there is one more example, the example of Euclidean geometry. What? Euclidean geometry. It has also some given facts or some given postulates or some given axioms. In fact, they are 5 in number, if I am not wrong. And according to those 5 postulates, I can play the game of Euclidean geometry. Okay, if I don't agree with at least one of the rules of geometry, I mean of the Euclidean geometry, we'll be getting a different geometry, a different space, and we are allowed to do that. In fact, in the 20th century, some of the rules of Euclidean geometry were turned around, especially the 5th postulate, and that gave rise to a completely new geometry. Euclidean geometry, and of course it is played according to 5 postulates. Okay, one of them is, if you have a given line and you have a given point. Okay, how many lines are there that would pass through this point and would be parallel to this line L? I am saying that if I have a given point, okay, and I have a given line, and I am trying to pass a line through this point, my question is, how many lines will be there that will be passing through this line and will be parallel to this line? In fact, there are infinitely many lines that can pass through this point P, but I ask you a question, how many lines are there that will be parallel to this line L if they pass through this point? Can I prove this fact? Can I prove this statement? The Euclidean geometry has no answer to that. Euclid himself took this fact as axiom. What? Euclid himself took this fact as axiom. It means that it has no proof according to Euclid. He simply wrote down the answer to this problem as there is. We write down this as there exists or there is. This is this logical symbol for there is. There exists only one line passing through P and parallel to L. This statement has no proof in Euclidean geometry. This is taken there as an axiom, and I was telling you that you can at your own will you can change the axioms of the given axiomatic system, but accordingly you will get a different kind of theory. You will get a different kind of results. And in fact, this was done in 19th perhaps or 20th century when this fifth postulate, this postulate was questioned. Okay, and that gave rise to a new geometry. We call them non-Euclidean geometry. क्या यानी कि मैं कहना चाहता हूं कि जो ये एक्शियम्स होते हैं इनको हम चेंज कर सकते हैं अपनी मर्जी से, लेकिन बाद में जो आपको हासिल हो जाएगा उसकी कोई गारंटी नहीं है कि whether that will be of any use or not. और ये बात 19वीं और 20वीं सदी में साबित कर दी गई जब बहुत सारे मैथमेटिशियंस ने इस बात पे शक किया कि we can derive this fifth postulate that was taken as axiom by Euclid. We can derive this from some more basic facts. I mean, those mathematicians were not on the agreement that this Euclidean fifth postulate is actually a postulate. They thought we can derive this fifth postulate from some more fundamental facts, and in fact it was done, and as a result we got a different geometry altogether, and those geometries are called non-Euclidean geometries. क्या? Non-Euclidean geometries. Actually this is quite simple to understand. फर्ज कर लीजिए कि मैं चेस खेल रहा हूं या मैं फुटबॉल खेल रहा हूं, and of course it is a given set of rules, and when it's played according to those rules. What if I change the some or all, at least one or all of the rules of a given football game? Of course the result would be different. Suppose that in football game, I don't know much about football, perhaps अगर मैं फुटबॉल में हाथ से फुटबॉल को मारूंगा, it is a kind of penalty. It's not allowed there. What if I change this rule? I say we can play with our hands. Of course, altogether, if I allow this rule, the football game at that time would be completely different. You would be having scenes like dishum dishum. That's not that football game that was earlier played. It's a different game because one rule has been changed. Okay, similarly, we can change the axioms or the postulates of a given axiomatic system, but there is no guarantee whether the resulting theory would be of any use or not. Okay, and this was done for Euclidean geometry in 19th, 20th century by thinking that the fifth postulate can be derived from some more fundamental laws, but from some more fundamental postulates, and as a result we got a totally different geometry that's called non-Euclidean geometries. And non-Euclidean geometries are the reason that we are able to describe general relativity. General relativity, it has something to do with non-Euclidean geometry. Okay, according to general relativity, the space-time does not obey the laws of Euclid. In fact, those the general relativity obeys non-Euclidean laws. By that I simply mean you can twist a given piece of space, you can bend a given piece of space, you can stretch a given piece of space, you can compress a given space of space, and when we do this geometry, we get what? The curvature of space-time. As a result, we get black holes. Am I done with the question? The question, what is mathematics and what is its nature? No, right now I am not done with mathematics. I mean, with this question, let me tell you something more about what is mathematics. Let me tell you that this mathematics has been broadly divided into two main sub-branches. One branch is called pure mathematics, pure maths, and the second one is called what? Applied math. What? applied math. Okay. Now we know a little bit about what mathematics is. Now I am trying to tell you we can subdivide this mathematics into two main sub branches. One is called pure math, second one is called applied math. What the hell is this pure math and what the hell is this applied math? Let me tell you what is pure mathematics. It's a bit difficult to describe this branch pure maths, but I will try to make it more simple. According to me, pure mathematics is a process of choosing an appropriate set or group of self-evident truths called postulates, or axioms, and then figuring out what is possible and what is not possible within the system. I wrote down that pure maths is a process of choosing an appropriate set or group of self-evident truths called axioms and then figuring out what is and what is not possible within the system. मैं कहना क्या चाहता हूं, जो एक प्योर मैथ है ना, ये एक तरह की एक प्रोसेस है. कौन सी प्रोसेस? जिस प्रोसेस में हम कुछ स्टेटमेंट्स लेते हैं जो कि सेल्फ एविडेंट होते हैं, जिनका ट्रूथ हम कंफर्म नहीं कर सकते, उनको हम एज स्टार्टिंग पॉइंट लेते हैं. तो उन स्टार्टिंग पॉइंट से हम फिर ये पता लगाना चाहते हैं कि अंडर दीज कंडीशंस, अंडर दीज प्रीमिसेस, व्हाट इज पॉसिबल और व्हाट इज नॉट पॉसिबल अकॉर्डिंग टू दीज रूल्स. कशर पे छुस बह यसान वन यह जन प्योर मैथ ना, यह एक किस्म सा प्रोसेस, कस प्रोसेस यथ मज सेल्फ एविडेंट ट्रुथ्स वुचान, तुम सिलेक्ट करान, तुम चूज करान, पे वुचान यमो एक्शमो, यमो सेल्फ एविडेंट ट्रुथों पे कम कथ पॉसिबल, यानी कि कम कथ नेर पोज और कम कथ मुमकिन क्या, यानी कि कम कथ ऑब्जेक्ट. वो प्योर मैथ. और बे वन बह कथ, क्या प्योर मैथ क्या युतुई ना, यह कंपैक्ट description of what is pure mathematics. I told you that what is pure mathematics? Pure mathematics is a kind of process of selecting or of choosing a given set of axioms or a given set of self-evident proofs and then trying to find out what is possible within this system and what is not possible within this system. That is what pure mathematics is. But there is one more simple definition or simple description of what pure maths is. Let me tell you what is that. Pure maths is the mathematics that is for its own sake, that is for its own sake. Wow. I wrote down that pure mathematics is the mathematics that is for its own sake. इसका क्या मतलब बनता है? बह दिम तुह एग्जाम्पल. यह प्योर मैथमेटिशियन Pure mathematicians te applied mathematicians ch say farak yazan azkis yemis Lauras to beyis Mujnun. Ye yutazan ashkas to muhabbat panwe farak, tizash farak, kemis pure maths to applied maths. Using pure mathematician chasan, Oman chunasan garzi kihin kya, using me math develop core, using me mathematical theory shus padan, ये लग्या कुछ पगह कि यह गया साइंस मज होत इस्तेमाल कि यह गया फिजिक्स मज होत इस्तेमाल कि ती लूख मे क्या प्योर मैथ it is the mathematics which is for its own sake. Pure mathematicians don't care about the applications of their theory. They love to be useless. Yes, pure mathematicians love to be useless. They find it a kind of badge of courage when somebody tells them that whatever you are doing, it is completely useless. A pure mathematician would not be ashamed by this claim. In fact, he will feel a kind of proud because pure mathematicians are the mathematicians that do mathematics not just to apply this mathematics for some practical application, but for their own satisfaction. Go is only pure mathematician, the applied mathematician choasan. Pure mathematician choakasan ak ashuk or is only applied mathematician choasan imsun muhabbat choasan matlabi. Kya? One garz kya shum, usually pure mathematician imsun garzi, usually theory should develop karan, ye lagya paga physics mas, ye lagya paga chemistry mas, ye lagya paga biology mas, ye lagya paga economics mas, imsun asi garz, you shasani pure math panni jay karan, taaki imis mere satisfaction. Imsun questionum ambar humut khada for in order to catch that thirst, in order to catch the thirst of answering those questions, he does that pure mathematics. Usually applied mathematician chosen by the name itself. Usually applied mathematician chosen. You should math a particular theory tulan, time a particular result tulan, patwushan yum kaitas gaisen istemal. Go behak vanith, usually physicist to chosen, usually chemist to chosen, usually biologist to chosen, or usually baki field on him was that chosen, you cheap pure math side as town. And pure math must is an applied math, is an estimal this practically. Agar ne pure math is learned, yet has get practically estimal care, Umunchuna does you hold from Mohabbat Asan. Kya, Bushus Tashi Totkal Mohabbat Karan, you call a massive wapas carrier. But you might have Totkal Dharapi, you thought sit me wapas Karapi, you call me wapas no, to correct me in car, bit in car, and Mohabati yoke. To fear a boot bit turbo, making you send you a Shukshana Asan, to have Mohabub Charmuania Macha. चाहे में फायदा वात मचा तेल मोहब्बत सुन यह फर्क जे प्योर मैथमेटिशियन अमिस दिया यह प्योर मैथ मैथमेटिकल थियरी कर माइंडस मज डेवलप अमिस दिया यह फायदा प्रैक्टिकली कि ना दियस यह तेल प्योर मैथ पढ़ान एप्लाइड मैथमेटिशियन क्या अम्स पार्ट में मैथ ये जरूरत लगे तथ होतन सह प्यार कर ये मे बास मैथ जरूरत लगन प्रैक्टिकली मे तथ मैथस मोहब्बत गो क्या वो प्योर मैथमेटिशियन बिजती गर्ज क्या मैथ असली 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 मोहब्बत जमान अशुक सह बेदगा कर चाहे मैथ प्योर मैथ दीनस कह या मत दीनस सह प्योर मैथ कर तिथे पे अशुक गुमुत चाहे सह मोहब्बत तम सुन बनिन या मा बनिन चाहे ठूक दीनस या उबा करनस तेल अशुक तम सुन applied math what is applied math? I can write it down simply as it is that branch of maths that finds applications in real world. Examples statistics, calculus, and etc. By that I mean ... So I wrote down that pure applied mathematics is that branch of maths that finds applications in the real world. Okay, कशर पढ़न समझाऊन Applied math, as the name suggests, is simply math which beakh learned yazan istimal gasan day to day life humans, like in physics, like in chemistry, like in biology, like in economics. Okay, or मैं वन तुम यह जन यह एप्लाइड मैथमेटिशियन यह जन अम सुन मोहब्बत अम सुन अफेक्शन यह जन अम सुन इनक्लिनेशन फॉर मैथमेटिक्स सह लिमिटेड कोत ताम लिमिटेड एज फार एज द लॉज ऑफ मैथमेटिक्स लॉज और रूल्स और द थ्योरम्स ऑफ मैथमेटिक्स आर ऑफ एनी यूज टू मी आई एम ए मैथमेटिशियन as long as they are of no use to me I have nothing to do with mathematics. That is why I say a pure mathematician is a true lover of mathematics. That means अमसुन मोहब्बत अशिक और यह एप्लाइड मैथमेटिशियन अमसुन मोहब्बत यह मैथ खतर सह मोहब्बत यह फर्क प्योर मैथमेटिशियन तो एप्लाइड मैथमेटिशियन. Was all about the first part of the question, the first question that was what is mathematics. Now let's tackle this second part, which is what is the nature of mathematics. So let me rub the board and I will tell you what is the nature of mathematics. Nature of maths, यानी कि मैं जानना चाहता हूं मैथमेटिक्स की खसलत क्या है, अत कुछ खसलत. ठीक, तो वलियो करो शुरू. बलिया की स्टेटमेंट पत कर इलॉबरेट. द मैथमेटिकल objects. By mathematical objects, examples would be what? Lines, angles, numbers, okay, intervals, integrals, derivatives, dot dot dot. These are the mathematical objects. Mathematical objects are lines, angles, numbers, intervals, integrals, derivatives, and other things. These are mathematical objects. Okay, I wrote the mathematical objects like these are abstract in nature. Okay, are abstract in nature. Dot dot dot. I wrote down that the nature of the objects that we deal with in mathematics are of abstract nature. What are the objects that we deal in mathematics? The objects for a mathematician are lines, are angles, are numbers, are topologies of several types of topologies, and many other things. These are mathematical objects. I wrote down that the nature of the objects that are of the interest to a mathematician are abstract in nature. So, sir, we are not able to grasp the meat of this statement. Will you please elaborate it? Of course, I will elaborate it for you. Suppose that let's for a while shift our understanding from this class of mathematics to a different, altogether new subject. Let me call that subject as stationery. Okay, let us shift our understanding for a while. We will come to the original question. But I will try to make you understand that statement that mathematical objects are abstract in nature. I am giving this analogy in order to make you understand that what does it mean that mathematical objects are abstract in nature. Okay, so let us suppose that we are not in mathematics class, we are in the class of stationery. Okay, and I am the teacher of stationery. Okay, what is stationery? I don't know. I don't need an exact definition of stationery. In fact, there is no subject at all with the name stationery that we learn in school or colleges. Okay, by stationery I simply mean Nazir Maktumun Dukan, like that. ठीक अत मज क्या स्टेशनरी मज क्या स्टेशनरी हज बुक अत मज कंटेंट्स क्या गोडनिक कंटेंट चैप्टर नंबर 1 पेन्स दोयम मार्कर्स त्रेयम चपटी चूरियम रफ पूंचम notebook. Let us suppose that the objects that we study in stationery would be pens, would be markers, would be scales, would be eraser. Okay, dot dot dot. So I am trying to tell you what is a pen. So let us start and suppose that our first topic is pen. What is pen? Once again, remember that we are no longer in a class of mathematics. We are in a class of stationery, and today our first topic is pen. Okay. Now, what is a pen? What is a pen? I can simply describe it. A pen is something which we use to write. Okay. Something which we use to write. Okay. I was telling you what is a pen because this is our first topic. What is a pen? A pen is something that we use to write. Of course, इसमें और कुछ भी होता है. It could be made of plastic. It could be made of a metallic body. It could be made of some other material, and it has several shapes like cylindrical. Usually, the pens are of cylindrical shape. Now, let us suppose that a notorious student, and a student with inquisitive mind, with inquiring mind, he asks me, sir, whatever you have told me up to now about pen, what is pen? I'm not satisfied with that. Please do one favor with me. Would you please show me practically what is a pen? And of course, it is not a hard job for me. I can simply open up my bag and show him this pen. This is the pen, or this is the marker. And when he asks me, sir, I'm not satisfied with the verbal description. I want its physical referent. Okay, and definitely I would be able to give him a physical referent for a pen. And of course, this student can now bite it. He can smell it. He can touch it. Means that a pen is something for that student that he can feel at least with one sense that he has. I mean, at least he can touch it. He can see it by his own eyes. He can smell it, and of course he can bite it. Means that this pen is something that is under the range of our 5 senses. Okay. Let us suppose that the next topic for us would be eraser. Eraser. And now let us suppose that my second topic is now in the class of stationery. It is eraser. Now I'm required to give the description of what is eraser. Now let me give the simplest possible one. An eraser is something that we use to erase something that we wrote. Okay, I wrote down that an eraser is something, of course, that we use to erase something that we wrote. One garu Meluk eraser क्या eraser छु सु चीज युस जन अस इस्तेमाल छन करन कम खतर कह चीज नहनावन खतर और बे क्या भी डिस्क्रिप्शनस मस दिस यह छु आसन यूजुअली रबडुक बनियोमुत ठीक लेकिन at the end of the description the same notorious student gets up and asks me, sir, whatever you have told me about the eraser, I'm not satisfied with that. I want its physical referent. And of course, this time also, I won't be wordless. I can show him an eraser. And similarly, he can touch this eraser. He can bite it. He can smell it. Means that he can at least use one of his five senses to feel it. Okay, let me shift this class from stationary to the mathematics. Up to now, we were dealing with stationary objects. And we found out that we can feel this pen, this marker, this eraser by at least one of our five senses. And we know anything that we can feel by our five senses, we call those things as concrete things. What? Concrete things. Of course, concrete is the opposite of abstract. What? Now, suppose that because we are now in the class of mathematics, what are the various mathematical objects that we are interested in? Possibly we could be interested in numbers. So let us suppose that I am trying to teach somebody what is a number. What is a number? Of course, I can describe this as a number is anything or something. A number is something that answers following questions. Like, how many and how much? By asking these two kinds of questions, we're actually trying to quantify the number of objects in a given set. And by this, we actually try to measure the magnitude of a given quantity. So I wrote down that a number is something that answers these questions. What is a number after all? A number is something that answers this question. What are the questions? How many or how much? Yes. How many apples do you have? I have 5 apples. How many? The answer was 5. This 5 is a number. How much weight do you have? Sir, I am 75 kilogram. This 75 is a number. So numbers can either answer how many of some objects are there in a given set or what is the magnitude of a given thing. So in this way, numbers answer actually these two types of questions. I can frame a question. How many pennies do you have in your pocket? I'm sorry, I don't have a single penny in my pocket. This single simply means 0. 0 is also a number. Now the same student, the same notorious student gets up and asks me now, Sir, I am not satisfied with the verbal description of what number is. I'm not satisfied with that. Can you show me a number? At this time, I would be wordless. I would be having no answer to him. Because he is simply asking me for a physical referent of number. Have you ever seen a number? The answer at this question is, I won't be able to show that student what is a number. Take it, this is 2. Take it, this is 5, and bite it and have smell of it. I cannot do that. Why? Because numbers are abstract in nature. That is why I say these numbers cannot be felt by 5 senses. Okay, it means that number, although it's a kind of thing, it's a mathematical object, but I cannot touch a number. But I cannot smell a number. I cannot show that student, take it, this is 10, this is 12, this is 100, this is 100 billion. I cannot do that because simply I cannot hold a number in my hand. It is something that is in my mind, in my brain. It is an abstract concept, just like love, just like hatred. Just to finish time, जिंदगी में कौन वोनमुत तो मे मोलो बड़िस बयस को ज्यादा मोहब्बत तम वोन तोड़ कूता ज्यादा कर मोहब्बत बस दपान 3 किलो तम खुद अलाव तो पाय उम्र त्यूता ईमानदार कूता ईमानदार 60 किलोमीटर ईमानदार We cannot measure imandari, we cannot measure honesty or love. These are non-physical quantities. But definitely, this concept of number answers some practical questions, but numbers themselves cannot be felt by our five senses. They are something like abstract entities like love, like hatred, like honesty. That is what I meant by that mathematics is an abstract subject. Mathematics is an abstract subject. The objects of mathematics cannot be felt by our five senses. That is what is the nature of mathematical objects. So I will wrap up. The nature of mathematical objects is abstract. And by this abstract, I simply mean they go around in our mind, in our brain. I cannot pull down 2 from my pocket and give it to yourself. I cannot have a line in my pocket or a triangle in my pocket and give it to you. These mathematical objects are something that whose domain is our brain. We cannot take them out from a school bag and play with them. We play with mathematical objects, but not by our hands, but by our brain, by our mind. That is what do I mean by that the mathematical objects are abstract in nature. Let me tell you one more thing for the nature of mathematics, and definitely I am damn sure that this time you will get it right. Okay, let's dive into it. So I was about to give you another simple description of the nature of mathematics. This time I will not be giving you some kind of description from some kind of standard books. It will be a kind of simple analogy. Okay, I will actually tell you who is a mathematician, and indirectly or as a logical consequence you would be able to understand what is mathematics, what is the nature of mathematics. You see kath me chi samjhawen chhan kam. What is chhan kam? To buse wana what is chhan. ठीक अम सत हेको अगर मे समझुन छान कम क्या दसिल कम क्या बह हेक इस पे समझ क्या वनु सा छान कुछ वनु सा दसिल कुछ तिम तम नफर छान कम तो दसिल कम कर, इसलिए दिम बह तुम डिस्क्रिप्शन ऑफ हु इज ए मैथमेटिशियन, तो तम सत लगे यह पाए कि मैथस क्युथ नेचर ठीक। क्वेश्चन, हु इज ए mathematician? Seemingly, this question is very simple, and of course, it has a simple answer as well. The layman answer, the simplest answer would be a mathematician. A mathematician is a person who is versed in mathematics. Okay. I wrote down that who is a mathematician? A mathematician is a person who has a good grasp in mathematical concepts. यानी कि साद अल्फाजन मज who is a mathematician? Mathematician छ आसान सु नफर युस माहिर छ आसान मैथ के इल्मु। ठीक, यह छ सा डेफिनेशन या यह छ सु स्टेटमेंट युस सारनी समझ या युस अख लेमेन थे पाने क्रिएट कर। हु इज ए मैथमेटिशियन? हु इज ए दसिल सु दसिल कम कर वन सा छान कुछ अगर छान सु छान कम कर तिथ पे लिख मे जवाब क्या वन सा मैथमेटिशियन कुछ मैथमेटिशियन सु मैथ जान गो यह सहल यह मे तीजा पसंद। बह वन तुम ब्या अम खुद सिंपल डिस्क्रिप्शन वो सा वो is actually my favorite one. I will write down a mathematician is a blind man. Note down these words. Blind man in a dark room A mathematician is a blind man in a dark room looking for a black cat. Looking for a black cat which is not there. What? Which is not there. Ooh, that hai. Dot. This is the description of a mathematician which I love most. And it reads, a mathematician is a blind man in a dark room looking for a black cat which is not there. The surprising part is this part, which is not there. Sada alfazan maz wan bh kus chu asan ak mathematician. Ak mathematician chu asan ak on nafar ekis anigate kamras maz yuzan ta chu asan chhadan ekis krihinis breadis ya bread lekin su krhun broad ya bread sa shantat kamras maz exist karan. Baker backlet repeat. Go yuzani mathematician chu asan yu chu ak on nafar ekis anigate kamras maz tat kamras maz chu chhadan kemis ekis krihini bread ya krihinis breadis yuzan hakikatas maz tat kamras maz su broad ya bread chu ke. ठीक yin tal tati fikri zi yuzani mathematical thinking cha asan ya yin tal tati yiti fikri how do mathematicians think kya toy kya shuba asan. As far as this sentence is concerned, it seems that mathematics is something that has no use at all. It is useless. But believe me that besides that, it also tells me a deep fact about the very nature of mathematics. What I was telling you before, I told you that the mathematical objects are what? Mathematical objects are abstract in nature. And by abstract, if something is abstract in nature, it means that it is beyond our five senses. That is why up to now, all these blind man, dark room, black cat, the important thing here to understand is this part, which is not there. What does it mean? It simply means that when it writes as which is not there, it means that a mathematician is dealing with something that is abstract. If something is not there, if you cannot touch, if you cannot feel it by your five senses, it is not concrete, it is abstract. It's beyond your five senses. That is why I am writing that which is not there. Go, isn't a mathematician chu asan? Emsans kaam kya chu? Emsans kaam chu cheezan pet sonchun. A mathematician, this sentence also tells me that a mathematician, just like physicists, just like chemists, just like biologists and other scientists, does not need a laboratory to do mathematics. Go math padne khatir shin se laboratory hajat, math padne khatir shi se bizadi ak mehaz ak kamra hajat, be rah to pen agar na suti aisi cheli yotkal se damag chu se hek math padit. ठीक गो मैथस कम ये अन चाने लेबोरेटरी सी गरज अन चानस रफस तो पेंसिलस गरज. मैथमेटिक्स इज अ गेम दैट इज प्लेड इन our brain, in our mind. It does not need physical reference. That is why I wrote down which is not there. Okay, go isn't it definition isn't it description of a mathematician इसमें यह हेचनावन ज isn't math छु subject यम खतर चे दिमाग छु अगर यम खतर चे सिर्फ दिमाग छु जरूरत यम खतर चे सिर्फ लॉजिक छु जरूरत क्या अगर चे लॉजिक छु से क्या मैथ पढ़ित ये थस कर बतो ब्या कथा क्लियर ज्यादातर इंसानन for most of the people the subject of mathematics they see it as a kind of ghost but believe me that this mathematics is one of our close buddies. We can deal with and everybody can study mathematics as long as he or she is possessing logic. And what is logic? I will tell you this way. If mathematics is the language of the universe, if mathematics is the language of the universe, and we know every language has a grammar. So what is the grammar of mathematics? And it turns out that the grammar of mathematics is mathematical logic or simply logic. With this, I end this lecture. In the next lecture, I will be dealing with how is mathematics related with other sciences, in particular with physics. Thank you.